Hey guys, this is Carrie. Let's do homework number 7. So let f of x equal 3 over 2x plus 6. Write the steps required to find f inverse of x. So step 1, when we're finding the inverse of a function, is to rewrite f of x as y. So actually I'm going to do the steps off to the right as we write each one of them. So our function is going to become y equals 3 over 2x plus 6. Step 2, let's go from the original function to the inverse. So switch x and y. So when we do this step, I'm going to change my color because now we've actually created a new function. This is not the same as the original function. This is the inverse. However, our inverse looks a little strange because y has not been isolated. So the next step is to isolate y. So we're going to subtract 6 on both sides. That gives us x minus 6 equals 3 over 2y. To cancel out division by 2, we multiply by 2 on both sides. We get 2x minus 12 after distributing equals 2 and 2 cancel here, 3y. 3y is equal to 2x minus 12. Divide by 3 on both sides. That gives us y equals 2/3 x minus 4 after we divide each of these by 3. Final step, since we made up y, we want to replace y with f inverse of x, the notation they asked us to use in the problem. For problem number 2, graph f of x, f inverse of x, and the line y equals x on the graph below. So I'm going to use blue for f of x, and then I'll use a different color for the inverse. So to graph f of x, we start at the y-intercept, which is 6. And we use the slope, rise 3, run 2, and then reverse to get all of the points that fit on our graph. And so here's f of x. All right, now in pink, I'm going to use to graph the inverse. So the inverse starts off at -4. And the slope says up 2 over 3, up 2 over 3, up 2 over 3, down 2 over 3, down 2 over 3, down 2 over 3. And so we have f inverse of x here. Finally, we're supposed to graph, and I'll use green this time, the line y equals x. So this is the 45-degree line that should be familiar from geometry class. It's the line that passes through all coordinates where x and y are the same. So this is y equals x. And just like we saw in class, this creates a pretty cool picture, something that should be familiar from geometry. So which of the following best describes the relationship between a graph of f of x and its inverse, f inverse of x? So if I compare f of x and f inverse of x, I really like the way that one of the students in class explained this today, which is if you took your paper and you folded it along y equals x, f inverse of x would land right on top of f of x. And so we have that f inverse of x must be the image after a reflection over the line y equals x, because it's exactly symmetrical across this line. For problem number 2, it looks like that's a typo, right? Oh wow, that was all problem 1. Problem 2, let f inverse of x equal -2 over 3x minus 6. Determine f of x in the form of a linear equation y equals mx plus b. So this one's a little bit weird looking because you start with the inverse. However, as we learned in class, the process is exactly the same when you start with the inverse for finding the original function as when we did the opposite in the above problem. So we're going to start by replacing f inverse with y. We're going to switch x and y, which creates a new function, which is now the original function, not the inverse. From this point forward, all we have to do is solve for y. Because it's x plus 6 equals -2 over 3y. Multiply by 3 to cancel the division on both sides. That gives us 3x plus 18 equals -2y. Whoop, I forgot my x. 3x plus 18 equals -2y. Divide by -2 on both sides. That gives us y equals 3 over -2x minus 9. And it's minus 9 because a positive divided by a negative gives you a negative. Finally, it's unusual to see a fraction with a negative in the denominator, so a positive divided by a negative results in the entire thing being negative. And so this is the equation for for y. But I have to go back to f of x. So that was not my final answer. The final answer should have been f of x equals negative 3 over 2x minus 9. The function g of x is graphed below. Use the graph of g of x to answer each of the following questions. What is the x-intercept? And actually, this one has many x-intercepts. So the x-intercepts are where it hits the x-axis. So the ones that are easy are probably the non-decimal ones. So definitely 2 is probably the easiest. But I'll go for completion here and do all of them. So this looks like something like 5.6 maybe. I'm just estimating. This looks like negative 3. This looks like negative 6.8. So I know a couple of those are decimals, which isn't great. But I guess I didn't think about those while I was writing the problem. But now that it's there, we want to include all of the x-intercepts. So we have 1, 2, 3, 4 of them. For the y-intercept, that's where a function hits the y-axis, and luckily, this time I don't have a mistake, it's only one place where it hits the y-axis. So the y-intercept must be 4. What is the domain? So the domain is when we go from the lowest x value, so on the x-axis, the lowest value would be this one. That's, wow, that was sloppy. That's negative 9. So we go from negative 9 all the way up to 6. So I'm supposed to use interval notation, so that would mean from negative 9 to 6, including negative 9, not including 6, because of the solid and empty bubbles. Next up, what is the range of g of x? So range is, and I shouldn't use pink again because I've already used that. I use this brown color. Range is going to be the same question that we answered for domain, but with the y values. So we're looking for the lowest y value right here, y equals negative 3, and the highest y value, which you might think is here, but actually we get higher right here. So that's y equals 7. So we have all the y values between negative 3 and 7. And the reason why I'm writing this with inequalities is because they asked for inequality notation. Lastly, because we actually achieve this maximum at 7, we'll have less than or equal to 7. For problem E, it says if g of 2 equals p, then how much is p? So it looks like we're looking for when is the input the x value 2. So let me erase some of this marking that I've already done up here. So when we have an input of 2, it looks like we have the point 2, 0. So that's going to be, that means that p must be 0, because when we input 2 in for x, the y-coordinate is 0. Next up, it says if g of q equals 2, so q is the input, 2 is the output, then how much is q? And I guess there's a couple of different options, but there's one that's probably the clearest based on the markings that I used. It looks like this point would be a good guess for it. So 1, 2, 3, 4, 5. So when x is 5, we have a y-coordinate of 2. And so q is 5. I would have also accepted some other answers for this, because apparently there are 4 other points where the y-coordinate is 2. But I tried to highlight this one. So yeah. A Wall Street broker has been tracking the value of a stock owned by one of his clients. The value of the stock for various years is given in the table below. What was the average, or was the average rate of change in the value of the stock greater on the interval 2003 to 2016, or on the interval 2012 to 2016? So since it says average rate of change, that's just code word for slope. So I'm going to find the slope on these two intervals. So I'll start with 2003 to 2016. So that will be this column and this column. So I'll do m equals y2 minus y1, so y2 minus y1, divided by x2 minus x1. So m is equal to, oops, and I wrote 2013, that should be 2003, right? So m is equal to 910 over 13. And I'm actually going to do the division here because it asks me to compare which the rate of change is greater in. So I'll do 910 divided by 13, and that gives me m equals 70. For the blue interval, I'm going to leave you guys to do this on your own because it's similar, and you'll have to do the final comparison yourself. Last question. The image below shows steps 0, 1, and 2 in a linear pattern. How many cubes will there be in the 123rd step of the pattern? So it looks like in the 0th step, I have 1 cube. In the first step, I have, let's see, 1, 2, 3, 4, 5, plus the one inside, 6 cubes. And in the second step, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the one inside, that's 11 cubes. So the overall pattern here seems to be that the number of cubes increases by 5 for every step number. So I'm going to make an equation. The number of cubes on the xth step is equal to start at 1 cube and add 5. That will take me to the first step. To get from the 0th step, start at 1 cube, and add 5 2 times. To get to the third step, I would add 5 3 times. To get to the fourth step, I would add 5 4 times. To get to the xth step, I would add 5 x times. So you probably would be used to seeing that in y equals mx plus b form, like this. So I'll put that in a box. Lastly, I'm supposed to find how many cubes are in the 123rd step. So I'll input the 123rd step into my function. And I'll find that on the 123rd step, I would have 5 times 123. I'm using the calculator off screen to calculate this, plus 1, and that would give me 616 cubes. Cool. Please make sure that you study tonight, guys, for your exam. And we're going to have a binder check tomorrow, too, so hopefully you have your binder in order.